that objects A and B are separately in thermal equilibrium, if objects A and B are separately in thermal equilibrium with object C, then objects A and B are in thermal equilibrium with each other. So if A and B means on their own, they're in thermal equilibrium with this third body, then we can say that these first two are in thermal equilibrium with each other. Now, the implication of that law, what does that law imply? Please write that all bodies are the same temperature. All bodies are the same temperature. Or all bodies in thermal equilibrium have the same temperature. Bodies in thermal equilibrium have the same temperature. Or all bodies are the same temperature, are in thermal equilibrium with each other. It's use of English. Both of them say okay. Siphon, what is the implication of zeroth law? Is that okay? Now, if work is done by the system, so from within, the system is working on the surrounding. So what is happening to the surrounding? Expansion. I don't know if you understand. So work done on a system, think of this object. Work done on a system is this pattern. Work is done on the system. So that will lead to what? Compression. But work done by a system is this way. And that will lead to what? Expansion. Is that okay? Please take note that whenever work is done on a system, when work is done on a system, the work done is negative. But when work is done by a system, the work done is positive. I'll give you the reason for that. When work is done on a system, what is work done? Negative. But when work is done by the system, what is it? Positive. What's the reason? Please. Let's take the words simply, one after the other. What does expansion mean? Did you answer yes? What does expansion mean? Increase in what? Shape. Okay, but better still, increase in size, but in this case, increase in volume. Are we listening? So when I say something has expanded, what I mean is that if it was at V1 and I come back to V2, or let me say initial and final, when you come back to your final, initial and final, if I say something has expanded between the initial volume and final volume, which one will be bigger? That is expansion, right? So final volume is greater than initial. Whereas, if I say something has compressed, what do I mean? So if I'm subtracting final minus initial, what will my value be? Positive or negative? So because of that, when it is negative, what will be the work done on? Negative. I don't even understand. So anytime you use work done on, so listen, take it this way, work done on, compression, decrease volume, negative work done. Work done by expand, increase volume. What is that? Are we together? All right, so please we continue. Now, another thing I would like us to take note of. All right, so please, thermodynamics, like I said earlier, thermodynamics is a study. Listen, please. Thermodynamics is a study of the relationship between force. So the board is our system. Any other thing that is not the board in this class is a surrounding. Are we together? This class is a surrounding. Are we together? So when I'm studying a particular quantity or studying a particular part of the universe, that part of the universe I'm studying is called what? A system. Anything outside it is called surrounding. So communication between the system and surrounding, and that communication will be that there is change in matter and there is change with energy. So that means constantly matter will be flowing from system to surrounding or from surrounding to system. Energy will also be moving either from system to surrounding or surrounding to system. Is that okay with everybody? That's called which kind of system? Open. For closed, what is a closed system? There is no change in matter. So think of closing something. So think of a cup of water. When open, If you allow, it can pour out. When that water is pouring out, you know you have lost matter now. So when water goes out of the container, that's loss of matter, but also loss of energy. But think of a system think of that water you brought out from the fridge. You have not lost anything, but you realize from it being cold, what does it turn to? Hot. So for him to change from cold to hot, what does that tell you? That there has been some change in energy. Are we together? So please, when I have a system and there is no change in matter, but there is energy transfer, that kind of system is what? Closed system. The third system is a system where there is no change in matter, no change in energy. That system is called what? Isolated. For most of what we do, we deal with which kind of system? Closed. Now, the next thing is now, what is the energy that is acting on a system? Three primary energies will act on a system. We have heat, internal energy, and work. But the one I care about the most is the energy that we have within that system, and that's called internal energy. What is internal energy? Internal energy is the sum of kinetic and potential energy within one system. Sum of kinetic and what? Potential energy within the system. Now, what is this sum of kinetic and potential energy given us? Or what is the notion? It is denoted as what? U. What's the SI unit? Joules. I established, and we should know, that internal energy is dependent on what? But it is not dependent on what? Volume. So dependent on temperature. That means if temperature should increase, internal energy will also do what? Increase. If temperature should decrease, internal energy will also do what? Decrease. But if there is a change in volume, does it affect internal energy? No. So a way we can define internal energy is that internal energy is given as, change in internal energy is given as number of moles times molar heat capacity at constant volume times change in temperature. So that you observe that whenever the temperature changes, what will be changing? Realize that if I'm dealing with a closed system, the number of moles will remain the same. There's no change in matter now. So the only thing that will be changing here will be what? Temperature. And when that temperature changes, who will be affected? I don't even understand. Are we together? All right, so that is that for that. Now for heat, what do we say heat is? Heat is a form of energy that can be transferred. You cannot forget that. A form of energy I can transfer from one body to another. And the basis for transfer is what? Temperature what? Difference. So what is temperature? Temperature is just the degree of hotness or coldness of any body you are dealing with. So now please take note that heat is always transferred from where? Hotter to cooler body. Hotter to cooler body. Example, your wonderful pot of soup while you are cooking. You now took a stainless spoon and drop on it. Initially the stainless spoon was cold, but because the pot is hot, you drop on it. After a while, when you come back, what will you realize? What will happen to the spoon? It will be hot. And which kind of heat transfer is that? Conduction. When there is contact, conduction. All right, so that is that for that. Heat transfer denoted by Q. Heat transfer. So heat denoted by Q. Measured in what? Joules. Now we mentioned zeroth law. Whenever work is done on a system, work done on a system compresses the molecules of that system. So think of pressing on something. As you press them, you make them smaller, right? So whenever work is done on, please take note that what is that called? But when work is done by the system, what is that called? Expansion. Now, please note, compression is decrease in volume. That means your initial is greater than what? Final. Whereas expansion is what? Increase in volume. That means final is greater than what? Initial. Please take note. Change in volume. Come back to this formula. Work done is pressure times what? So change in volume is final minus what? Final minus. So please, final minus initial. So if I'm looking at compression, between final and initial, who is bigger in compression? Initial, right? So if I do final minus initial, will I be having a positive answer or a negative answer? Example, let's use values. If your initial was 5 and your final is 3, of course this is compression, right? So when you now want to subtract, it will be 3 minus 5. What will be your final answer? So you realize that your change in volume will be negative. So when your change in volume is negative, what will happen to your work done? Negative. So work done on is always what? I hope we're together. Number 2 is work done by. If work is done by, that means your final is bigger than your initial. So if I use the same values, now 5 minus 3, what will your answer now be? Positive. So that means work done by is always what? Positive. Work done on is what? Negative. Work done by is what? Positive. Now we go forward. The next thing is the law, the laws. So I'll start with the first law of thermodynamics. First law of thermodynamics. Oma, Daughter of Zion, please. First law of thermodynamics. First law of thermodynamics. Just now moving to the next line, to the end. Help your friend. First law of thermodynamics. So I can't hear you. Okay. In summary, is that standard talk we used to talk? I want that simple one. The simple one. Okay. Yeah, conservation of energy. That's what I want to hear. You are speaking many English. So conservation of energy where heat loss, the heat gain. How do I put it? In the word is that there is no heat loss. There is no loss of energy. But energy can be converted from one form to another. Yes. So the idea that in a closed system, energy is neither created nor destroyed, but then it can be converted from one form to another. That's just the principle. So that if I'm looking at my system, if I should introduce my same system, of course, remember your system has an internal energy, right? Now, if heat is brought into the system, that heat that is introduced into the system will either come in to increase your internal energy or it will be used to do work. So heat that is coming into your system, it is not lost. When you introduce heat to a system, that heat that is coming is either going to increase the internal energy of that system or the system is going to use it to do what? Thing. So that means the change in temperature is what? I hope we are together. That's what I mean by something being the same. Now, please look up. Isothermal. If I look at this formula, who will be affected by change in temperature? So that means because change in temperature is 0, when you multiply, remember that formula I gave you. If you multiply 0 by anything, your answer will still be what? 0. So please take note that change in internal energy will also be what? 0. That means if I'm to rewrite this formula, what will I rewrite this formula as? Change in Q is what? Equals to what? Work done. So this is how we'll define it. That in isothermal process, any heat that's introduced into that system is used for work. In isothermal, any heat that was introduced into the system was used for what? Work. So heat that is introduced is used for work. Heat introduced is used for work. That is for what? Isothermal. Number 2, isovolumetric. Number 2, isovolumetric or isochoric. Whenever you hear the word iso, what does that mean? Same. When you hear volumetric, what does that tell you? Volume. Please, who is affected by volume? Work. And I write this same formula out again. I would say for isovolumetric, volume is, change in volume is what? 0. So that now means that my heat will be equals to this plus 0. I hope we understand. Like, what will be affected by change in volume? Work done is, that means it will be what? 0. I don't know if you understand me at all. Are we together? Man of God at the back. Are we together? The man in front of you. Are we together? All right. So please, isovolumetric, volume is constant. And it is 0. Constant just means that initial is same thing as finite. Are we together? Which one is adiabatic, right? So if change in heat is 0, come back to the same formula. It will be 0 equals to change in U plus W. Are we together? So if I make change in U subject of formula, change in U will be equals to what? What this means is that any work that is done by the system is at the expense of the internal energy. Any work done by the system will be at the expense of the internal energy. So whenever the system is working, it will be at the expense of what? Internal energy. What's your question? Adiabatic. No, if there is no